Alrighty. Like, looks like there's me a hard one. Let's see if it's a streak breaker. Block placement queries hard. There's an infinite line with its origin at 0, extending in the positive x direction, okay? You're given a 2D array queries, which contain two type of queries. For a query of type 1, queries at I equals 1, comma x. Build an obstacle at distance x from the origin is guaranteed that there is no obstacle at distance x when the query is asked. From the origin. So x is just the position on the positive x direction. Build an obstacle, okay. For query type 2 is going to be 2x size. Check if it's possible to place a block of size anywhere in the range 0 to x on the line, such that the block entirely lies in the range of 0 to x. A block cannot be placed if it intersects with any obstacle, but it may touch it. Note that you do not have to place the block. Note that you do not actually have to place the block. Queries are separate. Okay, possible to place a block size anywhere in the range. In the range 0 to x of size. Okay. It can't touch it. A block cannot be placed if it intersects any obstacle, but may touch it. So the obstacles can be like bookends. Return array results where results I is true if you can place the block on the specified in the specified ith query of type 2 and false otherwise. Okay. So it places an obstacle at position 2. So this is, can you place something of size 3 from 0 to 3, which is false because 2 is blocking it. Is this the query of return a boolean results of I is true if you can place a block specified? Is the query 1 always true? I guess? No. Okay. In the ith query of type 2 and false otherwise. Return a boolean where results of I is true if you can place a block specified in the ith query of type 2. Okay, so only type 2 queries adds a true or false into the output array. Okay, so 2, 3, 1, that should be true because you can place a 1 either here, pretty much anywhere. 2, 2, 2, that's also true because you can place it between 0 and 2. The query 0s place an obstacle at x2. Block of size 2 can be mostly placed before x equals 3. Yeah. Sure. Place a query, place obstacle at 1, or place obstacle at 7. Can you put something of size 6 before 7? That should be true. Place another obstacle at 2. Can you put something of size 5 before 7? That should be true. Put something of size 6 before 7 is false. Okay. So I think I understand it. Place obstacles. You answer queries where queries. Place a block of size something before x position given the obstacle is placed so far. Alright, constraints. 10 to the 4th queries. So it's like 15. There's 150,000 queries. 150,000. 10 to the 4th is 10,000. 15 of those would be 150,000. And x, position x is going to be 3 times query length, the minimum. So the position can be at most 5 times 10 to the 4th, so that's 50,000. So we could have some sort of position array, but probably not. Input is generated such that the queries of type 1 no obstacle exists at distance x when the query is being asked. When input is generated such that for queries of type 1 no obstacle exists at distance x. Okay, I think that just means there's no duplicate obstacles. The input is generated such that there is at least one query of type 2. Okay. Let's go and just make an answer empty array. So I'm gonna guess this is probably linear. Wow, this is a really low acceptance rate. First thing that comes to mind is you do a bunch of inserts on a sorted array. Doesn't seem very fast, but in theory that might be, what would that be? That'd be like n log n squared, or n squared log n. N squared log n, something like that. It's n squared log n, so that'd be too slow. Kind of want to have a sorting, right? Kind of want to have a sorting. How else would you determine the amount of spaces between the gaps? How else would you determine that? Two, 7, 2, 7. So when you place an obstacle at 2, your gaps are going to be a size 2 and then like infinity, or whatever x is minus 2, assuming x is bigger than 2. That's your gap sizes. So here, obstacles at 7 and 2. How would you parse that in some sort of data structure? If you had I wonder if you can do like a linked list, to be honest. I wonder if you can do some sort of linked list. That's an interesting idea. Unfortunately, a linked list would be maybe slow in addition. Insertion into a linked list is generally O of n. Unless you could somehow jump to a certain position in the linked list. So like I'm thinking of a linked list in terms of like if you had a single block, a single node in your linked list where each node is like, each node has the start and end of that kind of space. So it basically starts with 0, ends with infinity. And then each time you have an obstacle, you kind of divide that node into 2 nodes that are linked. I don't know that works though. So you divide, like if there's a 7 obstacle, then you divide the 0 to infinity into like 0 to 7, 7 to infinity. This definitely feels like an n squared solution though. And n squared is just going to be too slow. Because you'd have to find a way to jump to the node that you wanted to split up in the linked list. And also you'd need to maybe go through all the nodes. You need to go through all the nodes to see where the biggest gap remains. Oh, is it possible? Possible to, so we have it position 7, position 2. Query from query up to position X. Up to position 3 of size 2. Up to position 3 of size 2. Is it possible to maintain an array up to a certain position, the biggest block you can fit up to that position? I don't think that works, because then if you place a block 2, then the following positions need to update. All of them. All of them. So infinity is the size of the first block. Guess infinity is the size of the first block. Or the size, how much you can fit for the first block. Infinity, and then when you place 7, what exactly happens? You can change the infinity to become a 7 block and another infinity block. X in size is up to 5 times 10 to the 4th. Is the smaller of these two. So at most it's going to be, I think I can probably use this as the bound instead of infinity. So the biggest position or the biggest size? So maybe 10 to the 10 times 10 to the 4th might be some sort of, if you double it, like x plus size. You don't really have anything that's bigger than that. Okay, so maybe you start with not infinity, like 100. 10 to the 4th is 10,000. So 100,000 as the last position. So your initial block is 100,000. Then when you place the 7, that's 7 and like 999. 99,993 or 99,993. And then when you have obstacle 2, then how would you know to break that down? And 7, you put the 2 in front of the 7. Could start with could in theory start with something that is your sorted obstacle list. Sorted obstacle list. And you could start with your sorted obstacle list. That doesn't seem like a good idea. 2, then 7. Well, that would have it sorted, so you wouldn't have to worry about calculating the stuff. So if you know your future obstacles are going to be at 2 and 7, then you know that your blocks are going to be like 0, 2, and 2, 7, and then I'll call it 7 to the end position, whatever that position is. That's going to be your future. But maybe your current is going to be something in between there. Because by the end of the last obstacle, this will be your block intervals. We're in a Boolean array that is true if you can place the block in the ith query. This is actually quite simple sounding, but nothing immediately comes to mind as how to solve this. Placing stuff on certain positions. Each time you place the position, it's going to update one block. One block gets changed. One block gets outdated. One block gets outdated. And then it inserts 2 new blocks. Interesting. Maybe you just need to have so close. It seems like a heap would be what you'd want to store. A heap. Or a heap comes to mind to keep track of like the biggest block available, where the heap has tuples of has tuple of like free size and maybe like the low and high bound of the interval, and then you keep track of the largest blocks available, and maybe you have some some way of invalidating certain tuples based on obstacles in their intervals, right? So maybe the heap starts with a tuple that is like infinity size 0 to the n value, or n value size 0 to n value. That gets invalidated with something that is 0 to 7, 7 to... So the heap starts with maybe something like n value from 0 to n value is the size, and then after the 7 obstacle gets placed, it's going to be, well, technically this is still on the top of it, maybe. And then the size here would be 7 from 0 to 7, and the size of the other one would be, no, if this was an ordered, descending order, it'd be n value minus 7 from 7 to n value, and 7 size from 0 to 7. And then once you place in the 2, it would be the same thing as before, but maybe have another tuple that is 5 from 2 to 7, and 2 from 0 to 2. And some of these things become invalidated once you add stuff, once you add obstacles to break them apart. But it would need to, you would still need to know, you'd be parsing the obstacles list, or when you parse the obstacles in the queries, you would somehow need to identify how the obstacle breaks the blocks that are currently in the heap into 2, and then add those to the heap. Can I, this, oh man, if only this was n squareable for the time complexity. Just don't think it is. Don't think it is. Seven, how would you know if you have the 7 obstacles? How would you know that the current low and the current high above that is 0 and the end? Because if you did know that, then maybe you have a chance of creating these two intervals. And once you have the heap and know which ones are valid and which ones are invalid in the heap, then it's just a matter of, well, actually it's not just a matter, huh? You actually have to pull the heap stuff out and make sure the position is workable. Oh, fuck. Because the block could be something that's in the like upper range, and X in the query could be something in the lower range. So you'd have to work with that. Oh boy. Oh boy, oh boy, oh boy. Given 2D queries. If you for a query of type 2, check as possible place a block of size anywhere in the range. Anywhere in the range. return a Boolean array of results or results I. Man. So I wonder if I should try to what should I try to be solving for? Can I either solve for the single query case, having to deal with multiple obstacles, or maybe the multiple obstacle or the single obstacle case, having to deal with multiple queries. I guess maybe the single query multiple obstacle case is the kind of simpler one to start with. Single query, single type 2 query, multiple obstacles. In theory, if you had a single query and multiple obstacles, you ignore the obstacles that are after that query because they don't affect it. And then for all the queries of type obstacle before it, then in theory you can order that, right? Ordering of that doesn't matter, so you can do it. You could sort it. And then I don't think you can sort it in the long run though. 7 then 2 could be like 7 2 4 or 2 4 7 or 4 2 7. 7 then 2 then 4. Huh. What is going on? 7. Place one at 2. 2 then 7. Wonder. What if I did a binary tree? Interesting. What if I did a tree? Thinking of a data structure that I haven't really seen before, or maybe I haven't really seen problems with this. Or maybe I have, but I never really fully understood all the thoughts behind it. But what if I did a tree where each node, a tree where each node is this might be too slow. does seem like it'd be too slow in the worst case. So if you had a tree where each node was like an interval, and then each kind of leaf, not leaf, each childhood node is going to break that particular interval apart. So you start with the node that is like from 0 to end position, and then since you have a 7, that node gets broken apart from, I guess the two childrens of any node will be the two intervals that it would break apart into. So then it'd be 0 to 7 and 7 to the end interval. And then the next obstacle is 2. So then you traverse down to the 0 to 7 branch node. So like your tree would be like all the nodes, tree with interval nodes. Each node is an interval. Children break apart in the interval of their parents. The leaves are the actual possible intervals. And I guess each node has a value that is the node's value equals the maximum of all their children's nodes, because all their children's nodes indicate the maximum interval. But then that doesn't quite work even if you have like a, doesn't quite work if you have a certain position that you want to check, because that's almost assuming that your maximum of any interval is some arbitrary value, and your stored maximum is something. I'm not even sure how it would work in the start. Like maybe you have maybe two values. No, that doesn't work either. Oh, let's sigh. I wonder. Yeah, the export of this query, it's going to be tricky to even work with. Even if this tree idea works, I don't know if this tree idea works, because in the worst case, you can have something that has obstacles like 1 through obstacle 1, 2, 3, 4, 5, 6, all the way up to whatever maximum position that you're dealing with, all the way up to like 5 times 10 to the 4th. And then that would create a tree that is actually like, it would create a it would create a very hard traverse tree. It's all kind of, what's the term? It's just like a left side branching tree. Because you go from 0 to 1, 1 to end, and then you break, or maybe I guess it's right branching, 0 to 1, 1 to n, and then you break up the 1 to n branch into 1 to 2, 2 to n, then you break up the 2 to n branch into 2 to 3, 3 to n. So yeah, it's just, it would take n O of n to traverse that branching, and then even then, well, do you have to traverse the branchings? Do you have to traverse the branchings? So, do you have to traverse the branchings? What exactly are you going to store at the node of the parent? So if you have obstacle at 1, so your tree would have like 0 to n at the top, or 0 to some arbitrary e at the top, which branches to 0 to 1, 1 to e. How would you know that you can do something that is, let's say, 5? Feels like this is n squared. So you have to traverse the tree down to, you have to traverse the tree down. So the node's value here is e, but maybe you should be propagating upwards the children value. Propagate upwards the children's values. So when it breaks into 0 to 1, 1 to e, this thing has a size of 1. So the tuple size is size start low and high. So this is e minus 1. And then you somehow propagate this thing to become e minus 1 is the biggest free block. Is the biggest free block. Maybe you need to store so the tree construction, no, the tree construction, the worst case is n squared. Because you literally have to build a right-hand side tree that has like n elements going down the right side in the worst case. That's just going to be too slow. Just construction of that tree is too slow. Could you, there's a way to handle insertion into a binary tree that makes it not too slow. Otherwise, construction of any binary tree is going to be too slow. Like maybe you do some sort of rebalancing. Balancing the tree. That would be like 1, 1, 2, e minus 2, 2 to e. And this one becomes like 1 from 2 to 3. And then e minus 3 from 3 to e. So is there a way to rebalance it? Is there a way to rebalance it? Do this as your root node and construct this. Because then you'd have these as the left side node to it. No, how does that work? This is, no, won't work. That just doesn't work. Normally with a binary tree, when you rebalance it, it's like the elements below it are not inclusive within it. It's like the stuff on the left side is bigger than it, or smaller than it. The stuff on the right side children is bigger than it. But here the children are literally inclusive within the parents' interval. So you can't just like recenter this thing on that, I don't think. It needs to be very hard to imagine that. Linking stuff seems too slow. This is almost similar to a linked list though. Because this is basically like you have one element in a linked list and then that breaks into 2 elements in the linked list. And then you break this element into 2 elements in the linked list. Yeah, this binary tree idea is just some variation of the linked list. And the main issue with the linked list is again trying to find the correct interval to break, or the correct node in the linked list to break into 2 separate nodes. It's going to be an O of n deal in the worst case. I guess this thing is binary, so in the best case it's like O of log n. But in the worst case it's still O of n. Well, I was thinking that the recent problems have been a little too easy. Unfortunately, this is definitely not that. One, two. All right. I'm gonna call it this a night. I spent like an hour.